So if you've been calculating the molar mass the way I've taught you, that's going to help you a lot. We're going to learn a slightly different way to calculate molar mass that sometimes will save you a lot of time. Okay? A little bit different, but it's the same basic idea. Remember, the definition of molar mass is the sum of all the atomic masses of all the atoms in a compound, written in units of grams, and in this class we're going to set it equal to 1 mole of that species. Okay? So what we're going to do is to calculate the percent composition, we're going to calculate the molar mass first. So let's calculate the molar mass of just water. We're going to do the percent composition of water, okay? So the question, if you want to have one on your paper, and I would suggest you should, is a question like this: find the percent composition of water. Okay? So we're going to do the molar mass calculation a little bit differently here. Remember, water has 2 hydrogens. And up to now, I've had you add those hydrogens together. Right? Put 2 separate hydrogens here. But in this case, what I want you to learn to do, it'll make it easier for you if you do, is instead of adding 2 hydrogens together, let's multiply them by 2. Gives you the same answer, doesn't it?
That's what I've been doing it.
Well, great.
Multiply what by 2? Multiply you by 2.
There's decimal place there. And then we're going to just multiply this by 1. Going to add them together. And when we have empty slots to the right, we have to round off. So we underline the digits that are insignificant, those that result from that empty slot. At least that's the rule for addition and subtraction. We use an arrow to show we're rounding off. And so the answer is going to be 18.015. That 8 causes the 2 to round up to a 3 grams of H2O. And so what we've done is we've found the sum of all the atomic masses of all the atoms in the formula. We've written them in units of grams. We've written the answer in units of grams and shown the species. And now we want to also show that's equal to 1 mole of H2O. And you've completed a molar mass calculation as required in this class. Okay? But now we want to take this information and use that to find our percent composition. Yes?
Okay. What if that 4 was an arrow? Would we round off to 5?
Yes.
Okay.
Okay? All right. So the percent composition takes the mass of all the atoms of the same type and divides them by the total mass. So the total mass of hydrogens is this number right here. So to find the percent hydrogen, we're going to take this total mass of the hydrogens in the formula. 2.01588. Okay? Hydrogen. Percent hydrogens right here. We're going to take that number. That's the total mass of all the hydrogens in the formula. But that's got to be grams of hydrogen, okay? and we have a total mass of 18.0153 grams of water. And there's one more step anytime we need a percent. I have to multiply the whole thing by 100. Okay, notice that just like our percent composition, our percent yield problems, the units are going to cancel. Percents are unitless answers.
So we divide what again?
The total mass of all the hydrogens in the formula, that came from right there, by the total mass of the whole compound. Okay?
What's the total thing? Percentage of hydrogen?
What?
Oh, what you just determined would be?
The percent of hydrogen in the compound. No. No, you can't cancel this and this. Okay? We're going to interpret what that means to us, though. All right? So we're going to take that 2.01588 right here and divide by 18.0153.
I got no question.
Yes.
I never paid a percent of hydrogen.
Yes, that's the second step. That's correct. All right. Then we're going to multiply by 100.
It's 11.18.
Okay. We need to have the right number of significant digits. I've got 1, 2, 3, 4, 5, 6 significant digits there. 1, 2, 3, 4, 5, 6 significant digits there. So our answer needs to have 6 significant digits. 1, 2, 3, 4, 5, 6. And underline from the 2 over. Draw an arrow to show we're rounding off. And our answer is going to be 11.1898%. And this is where, Carolyn, we're going to interpret what's here. Percent hydrogen in H2O. Does that make sense?
How do you decide which numbers are the line?
Okay. With multiplication and division, the rule is you take the measured and calculated numbers and find the number that has the least digits and make your answer have the same number of digits.
Can you say that again?
What's that?
Can you say that again? About the thought?
About the significant digits?
Yes, sir.
Okay. The rule for multiplication and division. The rule for multiplication and division when determining the significant digits is you take all the measured and calculated numbers in the calculation, in the problem. All the measured and calculated numbers. Not counted numbers, just measured and calculated numbers. Take all the measured and calculated numbers and find the number that has the least digits. And round off your final answer so that it has that same number of digits. Does that make sense?
Yes, sir.
Okay.
You did the 18.0153.
Both of them have 6 digits, so it's the same. So I want our final answer to have 6 digits. All right, now, this is the first half of the problem. The other half is we have to find the percent oxygen. And it's done exactly the same way. So can you find the percent oxygen in water?
Well, you just take 100 and then subtract it by the percent hydrogen.
Oh, let's don't move ahead. Just do what I asked you to do just now. Do it the same way here.
I bet the way he said it was right.
Well, the problem is, if you do it the way he said, and you do something wrong here, both your answers are going to be wrong. But if you do it the way I'm teaching you, I'm going to show you how to check your answer at the end. Okay?
Chill out.
Come on, Mr. T.
All right, now I purposefully did not show you the work because I want you to find the answer yourself. You should know how to get this answer now because it's the same process as this one. Okay? But you, on your test and on any homework or classwork, you have to show me all your work.
So we do oxygen, the oxygen mass over the total mass.
That's it. Oxygen mass over the total mass. Cancel units. Multiply by 100. That'll give you that number. Yes.
The answer?
Yes.
The same thing as the last one? I thought it was the same for
Wait a minute. I'm sorry. Would you do me a favor and slap that young man right in front of you there and tell him to shut up? No, I'm kidding. Don't do that. What I'm saying is be quiet, Brandon, okay? All right. Brandon, you're so loud when you talk. Be quiet. Carolyn, go ahead.
Okay, so the last one on the...
Brandon!
He didn't even say nothing. He really didn't say nothing this time.
All right, go ahead, Carolyn.
Okay, the last one on the percent thingy, I thought it would be a 2 because it didn't round for the 6.
Yeah, but see, now I have a 0 right there in that place. I took the 15.9994 divided by 18.0153.
You circled the first zero, didn't you?
What?
I mean, like that first zero was your last fifth digit, wasn't
It's okay, don't worry about it. It's not important.
That's your answer after you rounded it, Mr.
Yes.
Can you move your couch out the way you move your couch?
Yes.
That's it?
Is that really it?
Say what, Morgan? Yes. Underline the 6 and the 7 in your unrounded answer. And then you round the 0 that's next to the 6 up to a
So
1.
you underline the 6, 7.
Yes. Okay. Now, that's it for finding the answer. Yes, indeed. That's it. It's really simple, right? However, you stumbled there on something that's really important because you can check your answer, and I always recommend you check your answer.
Why you got 6 digits? I thought it was 5.
No. This 15.9994 has 6 digits, and this number has 6 digits, so this answer should have 6 digits too.
I see one there.
Okay.
You got a 9.
All right. Now listen. If we've done everything right, then we can check our answer. We should be able to add both percents.
So shut up, Roman.
And get very close to, if not exactly 100. If your calculations are right, it should give you very close to, if not exactly 100. Okay, is that what you got?
Oh,
Can't get much closer to 100 without being 100, can you?
can't get no closer than that.
Well, you can't. It could be exactly 100, but it's close. I mean, well, actually, let's see.
Okay, I'll give you back.
Can't get any closer. You're right. You probably couldn't get any closer.